Welcome back, ladies and gentlemen. So we are going to take a look at our final piece for triangles today. It's called coordinate proof and mid-segment. I know I mentioned before about two column proofs that we were going over them, don't necessarily need to know them for the test. This, however, is very important. These are both right on the test, okay? Both on the test. Okay? So you really want to make sure that you know these two, okay? Alright, now, the first thing we're going to take a look at is something called a coordinate proof. Alright, so we have here, it says triangle FUN, fun, get it, like math, has coordinates F, U, N, using those following coordinates, using coordinate geometry, prove the triangle's isosceles. Okay, so first thing we're going to do is we're going to prove these, or plot these points. So plot point F, 2, 3, here is 0, 0, right 2, up 3. Okay, so there's my point F. U is 5, negative 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. I don't know why I'm putting that there. Why not keep it the same? And then N is negative 2, negative 1. Back 2, down 1. Okay. So here is my drawing. Okay. And I knew to connect those dots because it said triangle. In order to be isosceles, I need two sides the same. Okay? So we are going to be using good old distance formula. Now, here's the thing. You have to prove which two sides are the same. Okay? So if you guys can look at this picture with me, I have side FN, I have side NU, and I have side UF. Alright? Which two sides do you think will be the same? Hopefully you guys can see side NU and UF look very similar. So that's what I'm going to do. Here's NU first. Okay? I'm going to use the point negative 2, negative 1, and 5, negative 4. Okay? And I'm going to plug these into this formula. Alright? So we're looking at x2, I'll label them for you, x1, y1, x2, y2. So we're looking at 5 minus negative 2 squared plus, just following the parentheses, or the equation, which I will be given to you, y2 minus y1 is negative 4 minus negative 1. Alright, well, this is mostly calculator work. 5 plus 2 is 7. Negative 4 plus 1 is negative 3. So you're looking at 49 plus 9, which is the square root of 58, which, if I grab a calculator, the square root of 58 is approximately 7.62, rounding to the nearest hundred. Okay, so what you've done here is we've just proven the distance from N to U. Alright, well, I have to prove at least one of their sides the same. So again, you can do NF or UF. I'm going to try UF. Okay, because I think it's going to work. 5, negative 4, 2, and 3. Okay, so this was all for the first part. Okay, so here's my second part. X1, Y1, X2, Y2. I'm just back to doing the same idea here. Distance equals, we're looking at X2 minus X1, so 2 minus 5 squared. Y2 minus Y1, 3 minus negative 4 squared. If I clean that up, 2 minus 5 is negative 3. 3 minus negative 4 is 7. Things are looking good. I didn't really explain this in the last one too, but hopefully you're cool with it. When you square -3, okay, it's -3 times -3, which gives you a +9. Okay, so just be careful about that. It ends up being square root of 58, which we know is 7.62 from the last one. So that's UF. Okay, so what we write, okay, since UF is congruent to NU, triangle FUN is isosceles. Okay, and you've just proven it. I just want to show you guys one more thing too while I'm at it. These calculators are wonderful. You can use them. They're very handy. And I know this is tricky. This is a lot of hard math inside here. Okay, so like all I did was use this formula. If you have this graphing calculator, watch how I can type this in here so that I can do all the work right on it. There's a big square root symbol, second square root. Okay, I see a parentheses, so I do open parentheses. 2 minus 5, close parentheses, and I'm going to square it. The square button is right here. It's right below the x negative 1, 1. Cool. In between them is a plus sign. Open parentheses, 3 minus, open parentheses again, -4. Please note how I used a negative sign here as opposed to the minus sign. Close parentheses again, square it. Okay. Now if I hit enter, what do I get? Well, what do you know? The whole entire thing. I'm totally happy if you guys can write this first step out and use this to go right to the answer. Okay. Please get comfortable with these. I know math is hard. Let these help you out. Okay. Awesome. So is that a hard problem? It's a lengthy problem. Okay. It's definitely going to take you a little bit of time. You have to use distance formula. But you're trying, in this case, because it says isosceles, you're trying to prove two are the same. Had you found the distance from N to F, you would have not gotten 7.62. It's a little bit different. So then you would have had to do it again. That's why I'm telling you guys, open your eyes. Look at the picture first, okay? Don't just randomly guess, all right? Okay, so lastly, D, E, and F are all midpoints of the sides of triangle ABC. Midpoints mean it cuts the sides in half. So that would mean AD is the same as DC, CE is the same as EB, and then AF is the same as FB. If CB, that's this right here, is 7x plus 4, and DF, right here, 2x plus 11, then what is the length of EB, which is right here? Show all the work. Okay. This is called a mid-segment. Okay. So what does the word mid mean to you? Mid means middle, mid. So when it says midpoints, it's always half, all right? So basically what's going on here is this outside, okay, DF is the mid-segment of this triangle, all right? It is half of whatever this is, all right? So there's two ways you can do this. You can, all right, do 2x plus 11, which is the inside, okay? And you can times it by 2. I can double it. Double the inside. Double the inside. And you make that equal to the outside, 7x plus 4. The other option is to take half of the outside, but if you're taking half of 7, what's going to happen? You're going to get a decimal, 3.5, and it just gets a little bit messy. So this is probably your better option. Okay, I'm doubling the inside, making them equal. Double the inside, make equal to outside. Okay? Alright, since I have two parentheses, 2x plus 11, I can distribute that in. 4x plus 22. Okay, and now I'm just solving this problem. I need to get all the x's on one side. Subtract 4x, subtract 4x. Okay, now I can subtract 4 over. 18 equals 3x. And I can divide by 3. x equals 6. Okay, so always read directions, because they're asking us to find the length of EB. Oh no, EB's over here. Okay, well, take 6. I'm going to plug this back in. Okay, so I'm doing 7 times 6 plus 4. That's 42 plus 4, so 46. Now, CB equals 46. So what could EB equal? Well, it's just half of this. So I'm going to do 46 divided by 2. EB equals 23. Michael Jordan up in here, okay? So is that a hard problem? I think that one's pretty simple, actually, okay? It's just that you have to know mid-segment means middle, half, okay? You get the idea. 2 problems that you'll definitely see again, all right? So please make sure you're cool with that. Yeah, and we're in good shape, okay? Very cool. I always wondered this. So, like, I have this little, like, R2-D2 thing, and, like, it's one of those things where if you look through it, you can see the thing inside of it. So I always wonder if I held this up to the light. Oh my gosh, it works. Oh my gosh, it totally works. Oh, hang on. Oh, yes. Look at that. That's so cool. Oh, it's really hard to do this. Hey, look at that. That's so neat. You guys all see R2-D2. He says hi. He also says good work. Keep up the good work. As always, good luck. We're all counting on you. Haha.